This video provides easy-to-follow instructions for you to create this Frisbee using Onshape. Click below in the video description. Here you will find links to all of the resources you need to complete this project. First, there is a link for a PDF instruction sheet. Click this link and open the project drawings and specifications in a new browser tab. Next, if you don't have an Onshape account, use one of these links to create a free account at the Onshape website. Last, there are links for each of the segments of this video. The video instruction is organized into 5 segments. In Segment 1, you will read the engineering drawings. Segment 2 will establish the design intent. In Segment 3, you will create the part model using Onshape. Next, you will check the accuracy of your model by checking its mass properties. Last, you will check the design intent by making changes to the model to see if it will update correctly. Now you are ready to begin the project. In this segment, we'll read the engineering drawing for this Frisbee. Let's start by identifying the views provided in the drawings. First, there is an isometric view showing the Frisbee as a 3-dimensional pictorial. Next, 2 orthographic views. On the upper left is a top view. Aligned below this is a front view. This view is displayed as a section view, showing the Frisbee cut in half, exposing an interior profile of the part. The cutting plane line in the top view identifies the location and direction of the section view. To the right is a detail view. This shows an enlarged view of the front section, allowing us to view the details of the curved outer edge. When planning a parametric model, we first need to identify its basic shapes and included features. The top view shows the Frisbee has a circular shape. The central area is concentric and flat with a uniform thickness. The front section and detail view shows the outer portion as curved but not uniform in thickness. The bottom edges are rounded, forming small fillets. Next, we'll look at the dimensions and notes. First, the dimensions are in millimeters. The dimensions in the top view tell us that the flat circular center area of the Frisbee has a diameter of 160 millimeters. The front view shows the height of the Frisbee is 35 millimeters. The bottom outside edge has a diameter of 240 millimeters. The top part has a thickness of 3 millimeters. The outside curve is a conic arc with a rho value of 0.5, which makes it a parabolic curve and has arc value of 70. The detail view shows the bottom edge with a width of 4 millimeters, and the inside edge angled at 95 degrees. The bottom edges are rounded with a 1 millimeter radius fillet. The material is HDPE, high-density polyethylene. The mass units are in grams. Next, let's establish our design intent. To start, we need to identify any features that might be changed during the design process. We might want to make the Frisbee larger or smaller by changing the outside diameter. When the outside diameter changes, we want the inside flat diameter to change by the same amount. So which features should not be changed when the part is revised? The shape and size of the curve on the outside edge, and the material thickness. So how do we want the part to behave when these parameters are changed? If the outside diameter is increased, or if the outside diameter is reduced. Both the outside diameter and the inside flat diameter will change by the same amount. The outside curve will remain the same, and the Frisbee will update without errors. Before we model the part in Onshape, let's preview the steps in the modeling process. First, from the drawing, we will identify the profile we will use for the base sketch. Because this part is circular and symmetrical, we can use half of this front section profile as our base sketch. We will place this on the front sketch plane, with the origin at the center. We will use the sketch to revolve the Frisbee first as a solid part. We can then use shell to hollow out the inside to a uniform thickness. We will use sketch 1 again with revolve to add the extra thickness and angled inside around the edge. Last, use fillet to round the corners on the bottom edges, resulting in the finished part. So now let's get started in creating the Frisbee. I have started a new Onshape document and named it Frisbee. The workspace units are set to millimeters and the mass is set to grams. Start a new sketch and choose the front sketch plane. Use N to view the sketch normal to the screen. Use P to turn off the visibility of the sketch planes. We will start with a construction line at the center of the part. Click on Line and Construction. Click on the origin to start the line and stretch it vertical. Enter 35 millimeters for the height. Right-click and End Line. Now, click on Line from the Sketch toolbar. Click Coincident to the origin and stretch a line to the left for the bottom edge. Right-click and End Line. Use the dimension tool and click on the end of the line and then the center line. Move the mouse to the left of the center line and click for the diameter. Enter 240 millimeters for the diameter. We know from our design intent that this diameter may change, so let's set it as a variable. Double-click on the dimension and then use hashtag from the keyboard. Click on New Variable. Enter the name as OD for outside diameter. Use the green check to close. Use Enter to apply the variable to the dimension. Now for the horizontal line at the top of the Frisbee. Click on Line and start coincident with the top point of the center line. Stretch the line to the left. Right-click and End Line. Use the Dimension tool. Use the center line to also set this value as a diameter. Enter 160 millimeters. This line will also be variable, but it should change by the same amount as the OD variable when it is changed. We can set this relationship with a formula. Double-click on this dimension and enter hashtag from the keyboard. Choose OD from the variable list. This line is 160 millimeters, which is 80 millimeters smaller than the OD. So after the OD variable, enter minus 80 millimeters. Use Enter to apply the formula. Now as we change the OD variable, this line will also change, maintaining the relationship. Now we can create the conic arc that makes the curve on the outside. From the Sketch toolbar, choose Conic from the Arc drop-down menu. Click coincident to the end of the top line and coincident to the end of the bottom line. Stretch the arc outward and look for a horizontal icon and the row value to be 0.5. Click to set the arc and use Enter to accept the row value. A row value of 0.5 for a conic arc indicates that the curve is a parabola, meaning it has a constant curvature throughout its length, similar to the path of a projectile in flight. Click on the Dimension tool and set the arc radius at 70 millimeters. Use Enter to end. This looks good. Now we can sketch the angled line that will add thickness to the inside edge. Click on Line and then coincident to the bottom line near the outside edge, and end coincident to the curve. Use the Dimension tool to set the distance from the outside edge at 4 millimeters. Set the angle to 95 degrees. Last, to use this sketch for our first revolve, we need to close the region. Use a line to connect the ends at the center. This looks right. Use the green check to close. We can now use this base sketch to revolve a solid Frisbee shape. Click on Revolve on the Feature toolbar. For the sketch region, click on the Sketch 1 from the feature list. For the revolve axis, click on the line at the center. This looks good. Use the green check to close. We can now use Shell to hollow out the inside and create a uniform thickness. Click on Shell on the Feature toolbar. For the face to remove, click on the bottom face of the Frisbee. For the shell thickness, enter 3 millimeters. This looks correct. Use the green check to close. To add the material for the angled inside face of the Frisbee, we will use another revolve. Click on Revolve on the Feature toolbar. Click on the eye on Sketch 1 on the feature list to turn on its visibility. Click on the eye on the part in the parts list to turn off its visibility so we can see the sketch. Now, click on the region of the sketch with the angled line. For the revolve axis, click on the line at the center of the sketch. Click on Add to join this with the existing part. Turn on the visibility of the part. Check the box for Merge with All. This looks like what I want. Use the green check to close. Last, we need to round the bottom edges using a fillet. Click on Fillet on the Feature toolbar. Set the fillet radius at 1 millimeter. Click on each of the bottom edges of the Frisbee to round them. Use the green check to close. This looks good. The model of the Frisbee is now complete. In this segment, we'll check the accuracy of the model by checking its mass properties. To check the model, the mass units should be set to grams and the material set to HDPE plastic. If the size and shape of your model was completed accurately, the mass should be 238.751 grams. Let's look at this process step by step. First, open the document that contains the model of the Frisbee. Next, check the workspace units. And make sure that mass was set to grams. Next, set the material to HDPE, high-density polyethylene. Go to the part in the parts list. Right-click and choose Assign Material. In this case, we're searching for HDPE with a density of 0.001. Click to select it. Next, go down to the lower right corner and click on the Display Mass Properties button. When the dialog box opens, click on the part, and the display shows a mass of 238.751 grams. If this was your result, then your part is accurate and matches the specifications. If not, we can troubleshoot to locate the sketch or feature that has an error. First, locate the rollback bar in the feature list. Move the rollback bar up to just below Revolve 1. The mass now reads 1,489.796 grams. If you have an error here, examine Sketch 1. Now move the rollback bar down to below Shell 1. This removes material to hollow out the Frisbee. The mass is now 187.204 grams. If you have an error here, examine Shell 1 and the shell thickness setting. Now move the rollback bar down to below Revolve 2. This adds material for the angled inside edge of the Frisbee. The mass is now 238.952 grams. If you have an error here, examine Sketch 1. Now move the rollback bar down to the end. The mass is now 238.751 grams. If you have an error here, examine the settings in Fillet 1. You should now have found any errors and your part is accurate to the specifications. In this segment, we will make some revisions to the part and check if our design intent has been applied correctly. We will start by reading the revision drawing to identify the features that will be changed. First, the Frisbee is now bigger. The outside diameter at the bottom is 280 millimeters. This is an increase of 40 millimeters. With this change, the diameter of the flat inner area on the top surface of the Frisbee has increased by the same amount to 200 millimeters. If the part updates correctly, the revised mass should now be 303.365 grams. Now we will make the revisions to the Frisbee. I have opened the Onshape document that contains the part. In our design intent, we anticipated that the diameter of the Frisbee would change. So we set the bottom outside diameter as a variable, naming it OD for outside diameter. We also reference the same variable in a formula determining the diameter of the flat area on the top surface. When the bottom diameter changes, the top should change by the same amount. To change the variable value to make the revision, click on the button for the variable table on the right. Double-click on the value of the OD, which is the bottom outside diameter. Change it to 280 millimeters. I can see that the Frisbee updates without errors. Let's take a couple of measurements to check its new size. Use the rollback bar to remove the fillets so we can accurately measure the bottom diameter. Click on the Measure tool and click on the bottom outside diameter. This shows the diameter at 280 millimeters. Good. Use the space bar to cancel the selection. Now click on the line for the flat on the top surface. This now reads 200 millimeters, which is the correct amount. Close the Measure tool. In the feature list, right-click on the rollback bar and click Roll to end. Now click on the Mass Properties button on the lower right. Click on the Frisbee. The revised mass should now read 303.365 grams. Congratulations! If you got the same results, your Frisbee has been revised correctly and met our design intent. Thank you for watching. If you enjoyed this video, look for more projects at cadvideotutor.com. Also, hit the like or subscribe button. If you have a question, leave a comment.